At the centre of every piece of digital technology is a computer chip. But do you know what is at the centre of a computer chip? Inside each chip there are billions of nanoscale electronic components called transistors. Imagine pressing a light switch. A mechanical action controls whether a circuit is on or off. But imagine if instead of having to press a button, a switch could be controlled by applying an electrical signal. This kind of electrically operated switch is called a transistor. It's not easy to see inside a transistor, so this analogy uses water flow to represent current. The balloon is the channel through which water can flow, and so represents the transistor. There are three terminals: an input, an output, and a gate that controls the switch. Increasing the water pressure around the balloon squeezes it, forcing the water out of the channel until eventually it is completely closed and the flow is cut off. The channel in a transistor is made from a layered junction of two different materials from the family known as semiconductors. Like water pressure squeezing the balloon, applying an electrical signal drives charge out of the channel. This restricts the flow of charge until eventually the current is cut off. The unique property of an electrical switch is that the output from one switch can be linked to another, either as the input or as the gate. Because transistors can talk to each other in this way, they can be used to compare information and build circuits that can make decisions. We define a transistor in the off state as the number 0 and as the number 1 when it is on. The ability to compare complex combinations of zeros and ones is called logic circuitry, and means that transistors can be used as the fundamental component in digital electronics, with the latest generation of chips fitting over 1 billion transistors into an area the size of your fingernail. This combination of two water transistors is the simplest example of a logic circuit, an AND gate. Imagine you have a mobile phone with a password. One transistor can recover that password from a memory device, and a logic circuit can be built that compares that information to an input stored on a second transistor. Taking the most simple example, let's say that the stored password is 1, so we'll set the top transistor to on. The bottom transistor is used to store our input. Let's first try 0 or off. The system is comparing the two transistors, but because they don't agree, no current flows. Now let's try setting the input to 1. This time current flows because the two are both on. Because this particular combination of transistors gives a positive answer if both the top and the bottom transistor are on, we call it an AND gate. Connecting transistors in different ways, more complex comparisons can be made using circuits such as OR, NOR and NOT gates. So that's a simple introduction to the transistor, an electrical switch that is the basic component in computer chips.